Hello guys, welcome to EduMath, and in today's video we'll be tackling friction. Okay, friction. So the first thing we're going to do, we're going to look at what is friction. Okay, and we're looking at ways to prevent friction, the laws of friction, and the bodies on inclined plane. Okay, so stick to the end of the video because you stand to gain a lot of things, okay, for your JAMB exam. So the first one is, what is friction? So friction is a force which acts to oppose motion. Okay, it's a force which acts between two bodies and it tends to oppose the motion. So what I mean is that if the body is moving in this direction, the friction is opposing it in this other direction. Okay, so friction acts to oppose motion. It wants to stop the actual motion of the body, and it occurs in between two surfaces. So when two surfaces are in contact, there is friction in between them. Okay, now there are two types of friction. We have static friction and dynamic friction. Okay, this static friction can also be called limiting friction, while dynamic friction can be called kinetic friction. So static friction is the kind of friction which acts on the body that is at rest. Okay, where you need a force to start to move the body. The force that you must overcome is called a static friction. Okay, so this is the friction between a body and a surface when the body is at rest. Then dynamic friction occurs between two surfaces in contact that have relative motion. So when the two surfaces are moving, one is moving like this one is moving like this, and there's friction in between them, the kind of friction that is there is called dynamic friction. So this one is for bodies in motion, this one is for a body that is static, that is just in a particular place. Now the next one is coefficient of friction. Coefficient of friction. So the formula for coefficient of friction is F divided by R. F divided by R, where F is the applied force, R is the reaction or the weight of the body. So from here you can derive another formula for the force. You can say F is equals to mu R. This symbol is called mu. So this mu is the coefficient of friction, which is the magnitude of the friction, how high the friction is. So the higher the value of mu, that means the higher the friction. So that means when you have mu as 0, that means there's no friction at all. Okay, that means the friction is 0. Example, when you have two bodies that are very smooth, there will be no friction there. Okay, let's move to the next part. The next part is the laws of friction. Laws of friction. So the first law of friction is that friction opposes motion. That is true. Friction will act opposite to the direction of motion. If motion is like this, friction will act backwards. Friction opposes motion. Second one is friction depends on the nature of the surfaces in contact. Nature of surfaces in contact. Maybe the surfaces are smooth, or they are not smooth, or maybe they are rough. So the nature of the surface in contact affects the friction. Friction does not depend, or you can say friction is independent of the relative velocity between the two surfaces. Whether the surfaces are moving or they are not moving doesn't have any effect on the friction. The velocity of the surfaces does not affect friction. Next one is friction is independent of the area of contact. So whether the surface, the area of contact, maybe it is small like this or it is big like this, does not affect the friction. Friction is still there. Okay, friction is independent of the area of surfaces in contact. Now let's move to the next one. Now this is a body on an inclined plane. This is an inclined plane. It is inclined. Normally it's supposed to be like this, but when you now stretch it up, it becomes like this. So there is an angle here. The angle which this inclined plane makes with the horizontal axis is called theta. Theta. So theta is the angle. So since this body is on the inclined plane, the weight of this body will be acting downwards. Weight acts vertically downwards because of the acceleration due to gravity. That's vertically downwards. So when this body is here, the friction will oppose it like this, because if you place a body like this on an inclined plane, this body cannot move upwards by itself. It cannot move upwards unless you push it from this direction like this. You push it like this. But once you place this body here, this body will tend to fall down. It will fall down like this. So what is pushing it down is the component of this weight in this direction. Component of the weight along the inclined plane. And the component of that weight along the inclined plane is given by mg. W equals to mg. That's the weight down here. The component of the weight in this direction is given by mg sine theta. I will show you in the next video. Now, this next part here is the angle of inclination, and it is given by tan theta. So once you have a diagram like this, and you're told to find the mu, the coefficient of friction, the value is tan theta. Tan theta is the coefficient of friction when you place a body on an inclined plane. So mu is equals to tan theta. Very straightforward. Now the next one is the same idea, a body on an inclined plane. Now I said earlier that this body cannot move upwards unless you push it like this. Now if you're pushing it like this, that means the friction is acting backwards. Okay, now this body has been placed on this inclined plane, then definitely it will tend to fall down like this, and what is pushing it down is the component of the weight in this direction. Okay, and the angle of this inclined plane is theta. The component of this weight that is acting like this is Fa, and Fa is equals to mg sine theta. Theta is the angle of inclination of the plane. Okay, this other component here given by R is equals to mg cos theta. It does not have any effect on this body along this plane. When you have a force acting vertically upwards like this, it does not have any effect along a direction that is perpendicular to it, like this. If here is 90, this force does not have any effect in this direction. It only has an effect vertically upwards. So this weight does not have any effect like this on this body. It only has effect in this direction, which is tending to push the body downwards. So this body must overcome this frictional force trying to hold it down, because friction is like this, the body is trying to move like this. Okay, so Fa is equals to mg sine theta. So if this body is moving down, that means it has overcome the frictional force. That means the force in this direction is now bigger than the force in this direction. So you can say Fa minus Fr will give you what is called Ma, which is the second law of Newton's second law of motion. So Fa minus Fr is equals to Ma. And from here, you already know your Fa. Your Fa is equals to mg sine theta. So you can now say mg sine theta. You subtract the frictional force from it, and you get Ma. Okay, where A is the acceleration of this body in this direction. In this direction. So it's very, very straightforward. I'll give you an example in the next video. Okay, so don't forget that this weight does not have any effect in this direction. It only has effect in this direction. And the component of this weight that you need, that is applicable, that is useful to you, is Fa. And Fa is given by mg sine theta. Okay, you can see it's very, very simple. Now we have the advantages of friction. Okay, now friction helps us in the brake system of a car. Friction is used there. It is used for producing charges. Okay, when you talk about electrostatics, you can produce charges by rubbing. Okay, when you rub an ebonite rod, enables us to screw or nail, as in place, to put a nail or screw in place. Okay, it can also be used to sharpen metals like knife and so on. It can be used, it enables your vehicle to move on the road without skidding off. Okay, skidding off. And it enables us to walk. Without friction, you'll be able to walk. You can see friction is very, very important. Okay, friction also has its own disadvantages. Friction causes wear and tear. When you have two bodies in contact and they are moving and touching each other and scratching each other, over time it will cause wear and tear. It also generates undesirable heat. When you rub two metals together, when two metals are touching each other, rubbing each other over a long time, it will generate heat, and this heat is undesirable. Okay, it also causes fire outbreak. The heat from this point 2 can cause fire outbreak. Okay, and it reduces efficiency. The useful energy that's supposed to be used by the machine or by the body, it's being converted to heat energy, and heat energy is like a waste. Okay, so the energy or the friction will reduce the energy, which will tend to lead to what is called reduced efficiency. So the efficiency of this device or of the machine, okay, will not be 100%. It will be something very, very low because the friction has reduced some of the energy. So we'll move to the next part, which is how to reduce friction. How to reduce friction. So you can reduce friction by lubrication. When you use oil, you can use oil, or you can use grease to reduce friction. You can also streamline the body. When you use streamlining, you can use roller or ball bearings, like what you have in what is called Boris. Okay, you can use rollers or ball bearings, and you can also use smoothing or polishing. When you polish the surface or you rub it with powder, you can also call it powdering. When you powder the surface, put powder there, the two surfaces in contact, when they are moving against each other, the friction will be reduced. Okay, so these four things, or these four ways, can be used to reduce the effects of friction. Okay, so that is the end of the class. If you really enjoyed this video, give it a thumbs up like, subscribe, and share. Okay, the next video will be questions on friction. Okay, we're going to be talking about the calculations of questions involving friction. Okay, so let's meet in the next video. Please give this video a thumbs up, like it, share it, and subscribe. Thank you for watching this video. Goodbye.